This is Mr. Ward, and I'm going to walk through some of the magic tricks that we've created and this little reminder of how to do some things. And start off with the very first one that we did. And I'm using a tool here that you're going to want to become familiar with called desmos.com/calculator. In fact, I invite you to open desmos.com/calculator in a web browser as you watch this, and to pause this video from time to time and try the things that I'm doing. Now, you might notice I've just got text in these cells. These cells are typically used for equations, but a couple of things about desmos.com/calculator. If you want to put text into something, you can click the plus button here and select note. So that's what I've done there. I've got a note. If you want, the default is an expression. That's an equation or something like that. There are other things you can do like tables, folders, and images, which I'll get into in a later video. But for right now, just know that's how I got that text stuff. I just selected note and it gave me a note. So pick a number. Now, of course, picking a number involves an unknown. We don't know what they have picked, so a very common tool in algebra is a variable. So we're going to pick a number. I'm going to call it x. Okay, now take a look over here. When I picked x, what it did was it created a line. What it's treating this as is actually an equation, y equals x. Okay, Desmos assumes that I mean y equals unless I do something otherwise. So y equals x. And what that means is every point on this line, the y value equals the x value. You can think of the y value is what is produced by any particular x value. So if x is 4.75, y will be 4.75. And this is a very basic equation, y equals x, that we'll be running into from time to time. And you should pay attention to what this is doing. This is creating a line that is simply whatever x is, that's what y is. So right now, we have the original number. I'm getting rid of the y equals because we don't need it for Desmos. Now, I'm going to do the following steps. I'm going to add 8, multiply by 3, subtract 6, divide by 3, and subtract my original number. And it will end up in a particular place. You might guess that the original number is gone, and therefore it's going to probably end up at a particular number. Now let's see if we can use algebraic expressions to structure this. So when I add 9, what I'm saying is x plus 9. And now it took this line and it moved it up. Every point here, every y value is 9 more than whatever x is. So you can just click on the line, it'll give you points, and whatever x is, y will be 9 more right now. And that makes sense. We've just added 9. Now I'm going to multiply by 3. So I'm going to actually use one of my tricks with Desmos. I'm going to Control A, so that selects. I'm going to Control C. That's what I hit on the keyboard. Control A and then Control C and then Control V to just quickly copy that over. Now, I want to multiply that by 3, but I'm not just multiplying x by 3. I'm multiplying x plus 9 by 3, the whole thing. So I'm going to put parentheses around that thing, and I'm going to put a 3 in front. And that means that I'm multiplying everything there by 3. You might notice the line got a lot steeper. We'll learn more about why that line got steeper. But we definitely do not have a situation where we've pinned anything down yet. And so we don't have we're not getting a y equals x situation where we're back at our original number, and we're not pinning down any particular number. If someone picked, say 7, -7, they end up with something that's the outputs vary is really what I'm trying to say. So you're not pinning anything down. We're not done is really the point. And now we're going to take this equation here, Control A, Control C, hit Enter, and Control V. And I am subtracting 6 now. So I subtract 6. You might notice this line just went down to here. You don't have to know why these lines are doing these things yet. We'll learn about that later. But It is interesting to notice that these two lines are parallel and this one is shifted over a bit. Okay, now I'm going to copy pasta that, copy paste, Control A, Control C, click here, and then I hit enter, and it gives me the default setting, which is an expression. I can Control V to paste it, and I'm going to divide by 3. But if this is where Desmos is a little tricky, if I just hit divide, which is the / button, right there, I divide by 3, but I'm not trying to just divide -6 by 3. I actually want to divide the whole thing by 3. So I need parentheses around it all. And if I'm at the end of it and if I type in the in parentheses, it's actually going to understand that I'm putting parentheses around the whole thing. And then I do /, and now I can divide by 3. And it is no longer as steep. It's now as steep as this. And now it's back to here. Okay. Now I'm going to copy pasta this one more time, hit enter, and I'm going to subtract my original number, x. And when I did that, notice the line became horizontal. Now this horizontal line is a line that goes through y = 7. And whatever x is, it does not matter what x is, no matter where I drag my cursor around on this thing, y is going to be 7, no matter what number I picked. So what I have just established is that all of this business gets rid of x and leaves me with one particular number, the number 7. Okay, cool. I've laid out a little bit of how to do it, but how did all that happen? So I've set up expressions along the way, but really what would be useful at this point would be to simplify those expressions so we can see what's really happening behind the curtain. Because 3x and x plus 9 are pretty basic, but 3x plus 9 starts to get a little more complicated. So I'm going to simplify 3x plus 9. I'm going to say, let me just show you that 3x plus 9 is this line here. And I'm going to simplify it, and I'm going to say 3 times x, which is 3x, plus 3 times 9, which is 27. So I just distributed it. And you might notice that red line is on that same line as that. This means this is the same, has the same meaning. It's the same expression. Desmos is treating it as the same equation. Y = 3 times x plus 9. Y = 3x plus 27. Okay. Now, I subtract 6. So I'm going to subtract 6. This here is the fancy, complicated version, but I'm going to subtract 6 by just subtracting 6 there. So when I do 3x minus 27, so 3x plus 27 minus 6, I can actually get rid of 6 from the 27, and I'm left with 21, because 27 minus 6 is 21. And now it might become a little clearer how we're ending up with 7. See, we've got a 3x plus 21. Both of those are multiples of 3. If I factor a 3 out, like I'm about to do, this is going to end up being x plus 7. And that's what I'm going to do. I'm going to copy this down here. And I'm going to put parentheses and divide by 3, which is what I did here. These are the same exact thing, just this is fancier or more complicated, and this is simpler. And I'm going to now simplify it. By the way, once I've got the fraction bar, I don't need those parentheses anymore. So if I divide 3x by 3, I just get x. If I divide 21 by 3, I get 7. And I get rid of that. And now it's simply x plus 7. And when I subtract my original number, I'm saying x plus 7 minus x, whatever x was. And the x minus x goes away. They cancel each other out, and we're left with 7, which is in fact what we've got. So I hope that clarified a little bit about what we're doing. I'm going to now pause what I'm doing and clean some stuff up, and then I'll go on to the next one. Okay, now in the next trick, we're going to end up back at the original number. The last one their original guess that they picked. The last one we ended up at a particular number. So we're going to once again pick a number. So we pick a number, it'll be x. We will add 7, so it's going to be x plus 7. We don't have to do any simplifying. Once again, our lines are parallel, but it's been elevated up, so it goes through 0, 7 instead of 0, 0. Now I'm going to multiply by 4. So I'm going to copy this. Okay, I'm going to put parentheses around that. Go in front and put a 4. And now, this time I'm going to do the simplified version right next to that. This is the exact same equation. I'm going to multiply 4 times x and 4 times 7. So 4 times x is 4x, and 4 times 7 is 28. And I now have created a simplified version of this. Okay, now I'm going to do the fancy version and the simplified version. My next step is subtract 16. Okay, so minus 16. However, easier to subtract 16 from this. 4x plus 28 minus 16. 28 minus 16 is going to be 12. And you might notice I have 2 multiples of 4 there. And that's kind of handy because my next step is to divide by 4. Okay, I'm going to do the fancy complicated version first. I'm going to put parentheses around the whole thing and divide by 4. Then I'm going to use the simpler version and actually do the calculation. So 4x plus 12 divided by 4. Oops, by 4. All right, don't need the parentheses anymore. So 4x divided by 4 is just x, and 12 divided by 4 is 3. Get rid of that denominator because I just accounted for it. And now we're going to subtract 3. So we'll do it the fancy way. That. And subtract 3. And you might notice now that that's this line. I'm not sure why it does all of this stuff here, but it does. But at any rate, it is the same as y equals x. So no matter what x value I put in, I get the same output. It's always going to equal whatever x was that I chose. Okay, so this whole thing is just x plus 3 minus 3. So maybe that'll make it a little clearer that this is just x. Okay, I'm going to pause, and I'm going to clean things up, and we'll do one more. Okay, this time, instead of going to my original number, I'm going to go to, clearly did not clean one of these up. Okay, I'm going to end up at 0. I'm going to get rid of my original number, and I'm going to get rid of any other numbers. I'm going to end up with 0. In a different video, I'll show you how I construct these. But right now, we're just going to pick a number. So hit enter. I'm in an equation or expression form. So I do x. There's my number. Whatever my number is my number. That's why that line is y equals x. Then I'm going to multiply my number by 9. So 9 times x. I'm going to subtract 18. So 9x minus 18. I don't have to simplify anything yet at this point. But now I will. I'm going to be dividing by 9. So I copied that, put parentheses, / for divide, and divide by 9. All right, let's do so that's kind of fancy. Let's make it less fancy. Dividing by 9, we're just going to be doing 9x divided by 9, which is x, and 18 divided by 9, which is 2, so it's minus a 2, and we're just at x minus 2. Okay, let me get this fancy version because we'll need it. Now we're going to subtract our original number, minus x. Now, we've just subtracted x from this, but this is the same as just x minus 2. So now I will simplify what I've got. And since what I had, this 9x minus 18 over 9, was just x minus 2, I'm going to say x minus 2 minus x. And that cancels out the x, and I'm left with just 2. Okay, hold on. I'm sorry, I apologize. I am wrong. X minus 2 minus x. I get rid of x, but I'm not leaving a 2. I'm leaving a negative 2 because that was a minus 2. Okay, now we're going to add 2. Okay, I'll do the fancy version and the simple version. The fancy version looks like this, plus 2. But since we already know that this whole mess here is just negative 2, what we know is we're just saying negative 2 plus 2, which equals 0. So we just have a 0, and you ended up at 0. In a separate video or videos, I'm going to actually walk through some of my thought process where I'm going to materialize these math magic tricks pretty much out of a bunch of random seeming steps, but I'm going to try to reveal some of my strategic steps that I take along the way. All right, I'm going to stop this video now, and I hope it was helpful for you.